about the transfer of contaminants associated with microplastic to the biota. And let me introduce myself. I'm Dr. Jung-Hwan from Korea University of Ojeri. And in my lab, recently we studied the monitoring of microplastics in freshwater systems with emphasis on the occurrence of microplastics in the sewage treatment plant in Korea. And as you are all aware of the concerns about microplastic, so actually they found the plastic debris in the environmental samples, including some the macro-sized plastics inside the ingestion stomach and the ingestion systems of birds. And very recently, the people found that microplastic contamination is very widely found in the ocean environment. And now the people concerned have moved to the freshwater system. And this report has been reported by an NGO, and they sampled many sources of potable water and the freshwater resources, and then argued that the microplastic contamination is not limited to certain places, but it is actually the worldwide occurrence and worldwide concern. And very recently, the Springer published an edited book on the freshwater microplastic contamination, and arguing that contamination of microplastic in freshwater system is really an emerging issue with some specific areas. And basically, like other contaminants in the terrestrial system, we have many different sources of plastics in the environment. Some directly comes from the industrial facilities, and we use the plastic product in our plastic age, and then human consumption of macro-sized plastic will eventually end up to the environment unless it is properly managed. So one example that we have is the washing machine. So in our modern society, we use home washing machine using and cleaning our clothes, and most of our clothes are made from synthetic fibers. So using the washing machines, then it will end up with a lot of load of synthetic fiber, which is not easily biodegradable in typical wastewater treatment plants. So they review that the occurrence of microplastic in water treatment systems are found in many different places over the world. And recently we review the occurrence of microplastics in wastewater treatment plant, influent and effluent, and the values vary widely mainly because the method of isolating plastic has not been really standardized. So the primary goal of our study is a preliminary nationwide screening of microplastic, not only just for a few sewage treatment plants, but mainly covering most of large plants in South Korea. So in South Korea, we have roughly 200 large sewage treatment plants, and in this study, we picked up 50 large STP, and the annual, the daily discharge amount is greater than 500 tons, and they were chosen and we reviewed the sampling and isolation method of microplastics, and finally the microplastic that we separated quantified by Fourier transform infrared spectroscopy. And this list shows an example of the wastewater treatment plant that we picked up. And unfortunately, the data are shown in Korean, but you can also see that they adapt several different wastewater treatment processes. The A2 typical activated sludge system, and they use the bio sponge cube And some wastewater treatment plants, they treat the domestic wastewater at the same time with the industrial wastewater. And they're located in many different places over the country. So the method that we standardized for effluent, we flow through roughly 1,000 liter sample through this sieve, and after isolating the sieve, and then it was packed and then delivered to the lab for the further analysis. And in case of influent, where the concentration of microplastic is much higher than in the effluent, and we mix the influent storage tank and then sample roughly 1 liter, 3 bottles, and took small liquid from 1 liter to identify microplastics from wastewater influent. And the method has been reviewed in many earlier studies, and currently most widely used method of isolating microplastic from imported samples because of the large amount of organic matter in imported samples. We need to remove natural organic matter from synthetic particles. So typically they use the hydrogen peroxide oxidation method, and the sampled water was pre-treated using H2O2, and then by adding salt, we use zinc chloride in water, increasing the density of water. So the plastics are lighter than the fluid, so it floats up, and then natural clay particles, sand particles, they have larger density, they settle down. So after isolating floating particles, and then we filter onto the stainless steel filter, and then conduct the FTIR analysis. In addition to the isolating the plastics from imported sample, we prepared a kind of standard microplastic fragment using a polymer extruder. So this extruder is able to produce the fiber polyethylene with a diameter of 150 to 200 micrometer. And then we cut this into roughly 0.5 to 1 millimeter length, and this is the microscopic image. And then we added the counted particles, 10, 20, 30 to 50 particles to the influence sample, and see if we have the additional amount. And then the current method that we are using has roughly the recovery of about 90%, which says that the method is okay to isolate plastics from imported matrices. And the table here shows the preliminary results going on. We are accumulating sample actually, so we sampled 50 wastewater treatment plants, but in this presentation I only show 13 wastewater treatment plant results. And these count number of plastic particles per liter sample, and in the effluent we have much lower value. And typical removal rate in the wastewater treatment plant is greater than 99.9% in most of cases, especially when we use A2O process or the MBR process. The removal rate is greater than 99.99%. And if you use the sponge type, then it's slightly greater than 99.9%. And we also estimated how much microplastic that we generate by human activity. So among 13 STP influent, we counted roughly the number of people that each wastewater treatment plant support, and found that roughly 170,000 particles per individual person per day. That's the rate of production. And counting the fraction that is removed, then it ends up with about 100 particles in the effluent, which is analogous to the study from the United States, the Murphy and co-author. They said that the order of magnitude of plastic load to the environment was estimated as 100 particles per day and per capita, and it was more the same in Korea as well. The morphology of the plastic has been identified under the microscope, and we simply divide the particle shape into fibers and non-fibers. And fibers are quite abundant, and typical the material of fibers are layered, the synthetic fiber that are used for fabrics. And the non-fiber, somehow we found more non-fiber, the treated effluent. So this might suggest that fibers are more readily removed in conventional sewage treatment plant, but this hypothesis needs further confirmation. And one important finding from nationwide survey is that the particle size distribution. So we filter out the natural water with the sieve size of 100 micrometer, but still we find some smaller particles. And above 100 micrometer, the distribution of particle size follow the exponential function, which means we're likely to find more smaller particles in the environment. And if you use different cutoff, then the amount of particles that you can isolate from environment sample would be dramatically reduced. And the final assessment from pre-preliminary study that the performance of typical wastewater treatment processes on the removal of microplastics and the ATO, the anaerobic aerobic process, were quite efficient to remove the particles, but the sponge biocube method was less efficient to remove the particles. And the p-value between two groups of treatment processes show that it's less than 0.05, which means that we have significant difference between the A2O process and sponge biocube. So the final summary of our preliminary work is that we are conducting a nationwide preliminary survey, and this is the largest scale ever I know from different countries. And the number of microplastics that we estimate per capita per day is about 175,000 particles per human per day. And the layered, the synthetic fibers are the dominant form in STP, which are actually different from the marine microplastics. And the size distribution of microplastics that we isolated from wastewater treatment plant, they followed a power law, which means potentially those plastics are not really primary, but they are actually produced by fragmentation. And the removal efficiency of microplastic in typical ATO process was found to be excellent and higher than other biocube sponge process. And we are adding more data to provide more support on these hypotheses and the overall nationwide occurrence of microplastics in sewage treatment plant. Thank you very much for your attention. The moderator of the session. I think we have really limited time. So after each talk, we might have just one quick questions, and then if we don't have questions, then we move on to the next speaker.
So the microplastic may be suggested in the sludge.
Yeah, exactly.
Yeah, it's not really involved.
So we believe that the microplastics are not really degradable, and it must be found in sludge. And that's probably why the ATO process, which produces more sludge than the biocube sponge, has higher efficiency of removing microplastic. Good question.